You know that the hyperbolic cosine to the square minus the hyperbolic sine of the square of an angle is equal to 1. So the hyperbolic sine to the square will be this will be equal to 1 minus to the square, and this will be equal to the hyperbolic cosine to the square minus 1. So going with this rule over here, this will be like this. I'm going to solve only what is inside the square root. Well, so the hyperbolic sine is equal to the hyperbolic cosine minus 1. So I substitute that for the hyperbolic cosine to the square of wx divided by h minus 1 plus 1. I cancel this with this, and I get the square root of the hyperbolic cosine to the square of wx divided by h. So this will end up like this. Sorry, this is not to the square because this one, the first derivative, is only equal to the hyperbolic sine, not to the square of the hyperbolic sine. So I get the natural logarithm of hyperbolic sine. Sorry, hyperbolic sine of wx divided by h plus this one taking out other rule will be the hyperbolic cosine of wx divided by h. And what we have to do is to find out and to show that now this is equal to wx divided by h. So x will be equal to h divided by w by the natural logarithm of the hyperbolic sine of w divided by h plus the hyperbolic cosine of w divided by h. And what we have to do now is to show that, to prove that this is equal to of the tension plus the weight divided by h. And we will try to prove that. So we will leave this here and we will erase all the rest. Boom, boom. Well, now I need a little bit of my glasses, try to remember this. Well, TVH, our tension triangle on the hose pipe. Well, B is the weight of the chain. B is equal to W by S. The weight of the chain so T to the square equals to H to the square plus W to the square plus S to the square. So I'm going to substitute the value of S for the value over there. So T to the square equals H to the square plus W to the square by the H to the square plus H divided by W by hyperbolic sine of Wx divided by H to the square. So this means T to the square, H to the square plus W to the square by H to the square divided by W by to the. And now again apply this formula over here. So t to the square is equal to h to the square plus h to the square by this one, the hyperbolic cosine to the square of wx divided by h minus 1. And multiplying this, you will see that t to the square is equal to h to the square plus the hyperbolic cosine of to the square of w divided by h. So t is equal to h plus the hyperbolic cosine of wx divided by h. So t divided by h equals, so this one. T divided by h is equal to this one. So we have t. We are going to use the same order. It will be probably easier for us. Now, the next thing I have to do is to show, I have shown that t divided by h is equal to the hyperbolic cosine of wx divided by h. So here. And now what we have to do is that this one is equal to b divided by h, b being the weight of the chain. The weight of the chain. Boom, 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 boom. We'll see how I am able to do it. Well, I have said that the weight of the chain is equal to b divided by h, that the weight of the chain divided by h is equal to, very simple, because I remember that b divided by h was the first derivative, and the value of the first derivative was this one, the hyperbolic sine of the hyperbolic sine of wl divided by h. So I have here and b divided by h. Well, and also I can find out another one that will be something like that. If this angle will be alpha, so it's easy to see that b divided by h is the tangent, and it's also to see that t divided by h is the secant. So in case that we know the angle of tensions, the angle between the chain and the horizontal, that is quite easy to find out. So I can find out x with this formula too. Well, now I think it is not necessary to prove, because it's already over there, and probably this has been already proved, and now we have going to see what happens with that. Again, we say that y to the square equals to s to the square plus h divided by w to the square. So y over there is by the hyperbolic cosine of wx divided by h. We say that this to the square is equal to this one to the square plus Well, we will see. This will be ace divided by w to the square by hyperbolic cosine to the square is equals to ace to w by hyperbolic cosine to the square plus, well,